Good afternoon, everyone. Thank you for joining CPCI's webinar today on accelerated building construction. My name is Ariane Sabourin, and I'm CPCI's marketing manager. Today's webinar will be presented by Ken King from Hanscom Limited. For the past 41 years, Ken and Hanscom have been very involved with the construction and real estate development industry across Canada. Professionally trained and qualified as a quantity surveyor, Ken has 2 diplomas in urban land economics from the University of British Columbia, 1 in appraisal and 1 in real estate management. He has also presented programs featuring mortgage underwriting skills, consulting skills, public speaking, and management techniques to institutions such as Canada Mortgage and Housing Corporation, Business Development Bank of Canada, and the Certified General Accountants of British Columbia, just to name a few. Ken has successfully delivered quantity surveying, project management, and development management services to a wide range of P3, public and private sector building projects. Because of his ongoing commitment in promoting the advancement of building technologies, Ken has been a keynote speaker for the U.S. Green Building Council. He is currently writing a course for BC Housing on emerging building technologies through Langara College and was recently the independent certifier for the Surrey Biofuel Project. So without further ado, I will now turn it over to Ken King for the presentation.
Welcome everybody to our webinar today with regards to the accelerated building construction approach to doing all sorts of projects. So what we have here is a new paradigm shift, a new approach to doing projects. We are focusing on the precast concrete version of it, but modularity in construction is where we're moving to. And some of the great examples I've got for you today in this webinar really revolve around the wonderful products that the precast industry have to offer, and the projects that we'll represent will show you that. So accelerated building construction, also known as ABC, basically redefines how we plan our projects, design our projects, how we procure them, and of course how they're constructed, more of an assembly process, and the commissioning that happens thereafter. There's a lot of benefits out of all of this, and it minimizes the amount of mobility impacts that you have on projects that we typically see with standard construction, which really can be very disruptive to an area. So some of the intrinsic benefits include lowering our capital costs, basically shortens overall timelines. Some of these timelines can be shortened very dramatically. We of course improve our site safety and security. There's less disturbance on the site, it's a much cleaner site. We're going to gain a lot in project quality, and we've got many examples of that. We're going to enhance project durability. We're offering more opportunity to engage technologies into the project. The one benefit of these systems, of course, is that we have applications to install in a factory setting, and that makes it much easier to put in new technologies that are really wanted in the new building systems. We're reducing long-term operational costs. We're limiting our social impact costs. And of course, we're limiting environmental impacts as well. I do notice I'm getting some questions early on, and we will answer them as best we can. I might leave them towards the end of the program today, but if there's something topical as we're coming up with it, I'll do my best to respond to it verbally. Now, to carry on, areas where ABC improves projects is in the area of complete design integration. It's vital that design integration is used on an ABC project. What makes that really impactful is in the area where we see BIM being applied. Anybody who's a BIM proponent is going to really love ABC approaches to construction. So site constructability is worked out very early on. In fact, much of the project is assembled, not so much constructed on site. That improves a number of factors, including access to, the number of people you need on site, the ease of installation. It's more of a understandable, intuitive process. It's much easier to build these projects, and again, we have lots of examples of that. Site security is improved during the project, less to watch over, more just-in-time construction. Total project delivery time has dropped dramatically. Again, we've seen some incredible improvements on time, and I've got examples of that. Project zone safety for workers and the public alike is much better. And project durability usually goes up. In fact, because we're working in modular systems, we are often building for that modular approach, and therefore everything we put in has to be that much more robust, and it shows up in the project. And of course, access to the leading edge technologies for buildings is more apparent, more available. It also reduces such items as construction interference with the public. Quite often we can work around public, really sensitive areas and public demands, and that really helps us when we're using the ABC approach. Traffic impacts can be lowered dramatically, even though we're often moving large pieces. It's very minimal, the amount of time that it's affecting traffic. Therefore, it's not an elongated or extended process. On-site construction time is shortened dramatically, as I mentioned before. Material wastage is really reduced. The one project I can think of had one construction bin for the entire project, and it was emptied once. So that was pretty low for a full-size project. Site laydown area, staging, and storage areas are often minimized, and coordination of that is actually quite simple. Weather-related time delays are minimized, especially in today's changing climate conditions. That could be very important. And of course, overall financing and borrowing costs actually come down. Now let's look at a project from the point of view of a user. They didn't realize they had an ABC project. This video will tell you what they thought of the project.
Hi, I'm Licia Mullings, and I'd like to take you through our home. Bright colors provide stimulation in spaces specifically designed for dementia residents. Doors are paired together like duplexes with colored porches to provide a wayfinding experience. Upstairs are 6 supported living neighborhoods, each with its own dining space and servery. There's ample room for relaxing and spending time with friends and family. Our residents love the abundance of natural light and the warmth of the interior finishes. Central care stations offer a clear view to all residents' front doors. Each neighborhood has 33 private suites, including some for couples. Come inside. Each has its own kitchen, television, and barrier-free washroom. Secure gardens provide a safe outdoor experience.
Clients really loved the project. They have no idea that it was a modularized project with all the intrinsic benefits that come with it. They just noticed they got a wonderful project out of it. And certainly the quality is there. So where did it all come from? Well, originally, this actually started with the U.S. Department of Transportation, their Federal Highways Administration. They're the ones that came up with the approach of modularizing a lot of their major systems, and they use it for things like overpasses and major highway sections. And it really became part of a process that they championed back in the 60s to really move along and get large portions of infrastructure put in. So it's got a proven track record, and we've now been bringing it into all sorts of infrastructure, including buildings, of course, and that's where the real benefits start coming in. The ABC process provides great flexibility across a wide variety of project types. We're mostly going to be talking about residential project types in this demonstration today, but you will see opportunities to look at all sorts of buildings using this system. And of course, it doesn't have to look like a box. Although if you want it to look like a box, it certainly can do that. This is a model of a project that was put together to be put in northern Alberta. And you can see this going in any major center anywhere in North America and Europe. The ABC process allows unique solutions not offered by many site-built approaches. In this one, of course, we're looking at doing all sorts of modular units that get inserted into a structural frame. So this gets to be logically rethought when you start looking at how you build things. Wouldn't it be nice if everything you did was undercover and the roof was already on? In this application, the approach was to put a roof on before the building was actually finished and then insert the units thereafter. You can see these units are blocked out as models. And that gives your client a lot of opportunities. An approach like this would allow you to have a presentation suite, do all your rework, pre-finish work ahead of time before you actually install it in the project. And the level of quality control on a product like this would be superior because you wouldn't have to accept an inferior project on site. It would all come out with all defects gone and just be inserted into the project. So the ABC process is only limited to the team's imagination. This is an example where their imagination worked, and when we ran the economics on this project, it looked very favorable. And you'll see examples of that where it's been done in the past. The ABC process was critical in the overall development of major community development in Fort McMurray back in 2006. And I was involved in that project. And we did 9 prototypical condominium apartment buildings using a panelized system that did precast walls, floors, and roof assemblies. This was called the Eagle Ridge development, and its highlights included primarily 6-story tall buildings. They're 150,000 square feet with 1 level of underground parking. And the underground parking effectively ended up being free to the cost of the building because, you know, we basically just needed to cap off from the structure that was poured in place below that. Each fully finished building was completed in just 55 calendar days by a crew of 6. That included a crane operator, the project manager, and 4 basically installers. And it took about 2/3 the cost of standard construction at that time. In the photos that follow, you'll note how clean that site is. This is something we're quite proud of. And because of the diversity, the same major residential development used the ABC process to replace a $20 million bridge design, overpass design, with a $6 million solution. So again, the modular approach really came to the fore, especially back in the whole highways and overpass systems. Here's a picture of the project as it existed before the fires in Fort McMurray. A bit of an aside on that, they had some major fires in the area. These buildings basically went unscathed, even though there were lots of fires around them. I think they had some damage to the roofs where they had to be repaired, but that was the only place where the fire had actually damaged the buildings whatsoever. So they actually withstood fire very, very well. Here's some other pictures. The top 3 photos do kind of show part of the process while it was under construction. And basically, as the buildings go in, they are fundamentally finished. So they kind of go up in a completed state. Inside, of course, you're looking at the quality that would match or surpass anything that was being built in the area at the time. So you had a premium project for a very affordable cost at an accelerated time, and the quality, fit, and finish was basically unparalleled for the area. I've got another video here to show you. This one is from the architect's point of view of that previous project you just saw.
I'm Christopher Babbitts from FWBA Architects. The decision to build with precast concrete informed the design, and our approach was to turn limitations into opportunities. Concrete surface treatments and creative use of color, texture, and depth enabled a 4-story design to harmonize with a 2-story neighborhood. A hollow core floor system, together with innovative delta beams, offered us the thinnest floor structure possible. A 4-story design was achievable within the zoned height restriction, which maximized the land value. As architects, we are always looking for performance, durability, and sustainability. These locally manufactured concrete panels may look like wood, or stone, or stucco, but have a radically longer anticipated life cycle. This is a place for people.
Now, I want to reiterate the whole look thing. Those panels are all embossed. The project I showed you earlier in Fort McMurray was all embossed. The one complaint we had when we originally put the project together is that the brick looked too perfect. We actually had to go around and discolor the brick slightly to give it a bit more natural look, but the fit and finish is superior. You can basically get with a modular system, especially in precast, any kind of finish you want without actually having to go to the great deal of expense of bringing in original finishes like stone or wood or so on, and yet you end up with something that surpasses their durability, especially in the areas of things like wood. So you end up with a better product for less money and much easier to put together. Now, here's a project that's very interesting where they used ABC, and it wasn't actually what they did out of the start. It's called the Barrel Yards in Waterloo, and the project was originally started as a cast in place project. And the owner was pretty savvy. They realized they weren't going to do very well if they kept going with a standard cast in place project. So they had 2 towers going at the same time, and they stopped one of them. And basically, they stopped one of them and let the other one carry on as cast in place concrete. And for 3 extra months, they went and redesigned it. They switched it over to a modular precast system. Now, these 2 towers are 25 stories. They had 357 living units, and it was a large project, 450,000 square feet plus. They really wanted to maintain the design intent throughout the system. So when they switched over, it was a very stringent requirement to the designers to rethink this in an ABC system. And when they got to the precast concrete specialists, they had to come up with solutions that match what they were going to get right out of the gate using cast in place concrete. Even with that, and they gave actually it was a 6-month head start to the other building, they did beat the other building when they went to full modular, the one that was already being done in cast in place. They beat it by 4 months. Now that, that's literally like giving somebody a 6-month head start and, ending up in front of them. So they're basically at walking pace. And as soon as you go to ABC building construction, you're at a sprint. The architects were willing to accommodate any of these minor adjustments. There are some practical requirements that have to be taken into account, but it didn't really affect the building and ended up with a superior building, both saving time and money, especially in project financing costs. And trust me, your clients want to know about that. Some more photos of that project. And one of the things that's not shown easily in all these photos is once you get into the modular system, you end up with a very clean site. Here's another example where the modular factor really played well into how a building appears. And we actually have a current example of that in Vancouver where its modular elements were used in a major tower just off the Granville Street Bridge, and it really looks nice. So in this one here in Kitchener, Ontario, basically you've got these 3 distinctive towers of the Kitchener skyline, and they really wanted to make an impact on how they look. They went to the ABC approach, and basically what you've got here are 14 stories for building A, while B and C were a little bit smaller, and they were all built in a similar kind of a precast above, system, and it had above grade parking and everything. The building B started in March and was completed in May to the 10th floor. And that's pretty darn fast for something like this. Building A used a total of 1,290 advanced precast elements, and the heaviest of it was typically the exterior balcony of 164 square feet. But, the cranes and everything are designed to carry all that. And of course, building B had 1,100 of these units. C was very similar, a little bit smaller. But you end up with a project that was 40,000 square feet overall, and with very iconic views, very striking, architecturally, compelling views. And we see a lot of this using the geometry that was available to them and looking at the elevations that were, going to be so predominant in that area. This became one of Kitchener's, I think, really go-to look at projects. There's some other examples really looking at that balcony. And again, that was all modular and was installed in place. Now, quite often we're dealing with areas where there is an existing style, there's an existing kind of a community finish we want, especially in areas that are heritage looking, and there isn't a lot of room. These are urban areas. I'm getting asked if there will be photographs of the actual erection. Absolutely, we're coming to it. I'm just showing you some of the beautiful pictures. And of course, the president, there will be a document available later. Those are some of the questions I'm starting to see. The other question I'm getting, and we'll get back into this, is what's the cost per square foot? Depends on the project. So I can't really answer that specifically. It depends on what type of project you're dealing with. So anyhow, with regards to this one in Hamilton, they had an existing heritage area. They had to put a new building in a very tight urban setting that had to reflect the neighborhood. The benefit here, of course, is you can get that style, you can get that finish, and because you're working with a accelerated building construction method, you don't have to need a lot of space or take a lot of time for putting something like this up. So this one here, 149 project, includes highlights such as it's 7 stories tall. It had 73 1- and 2-bedroom units. So it was a rental situation. So cost was very much an issue. The site was very, very tight. So the ABC approach afforded them access where they typically couldn't get it. Each of the 9,000 square feet floors had 7,600 square feet of exterior wall, and that was all installed in 5 working days. So you're able to put these floors in 5 working days, and each pre-finished exterior panel was created with an almost ready look. Basically, when we take a look at them, the only thing they didn't put in, and of course nowadays we do, is they didn't put the windows in, but you fly them up now, all pre-finished. Traffic congestion, of course, was minimized because of the the just-in-time delivery, and of course that created a very positive image for the project in the community. They didn't see it as a bother too much. And it was actually kind of fun to see because basically this building looks like it grows in front of your eyes. City of Hamilton required the building to match the existing surroundings and have real, brick and stone look. So this was very, very vital in doing this kind of project. The workmanship on this really matched the area. In fact, it did a better job of it, and it created a really traditional historic look for a new building. So some interesting facts from this project include it had 52,000 square feet of 8-inch load-bearing and non-load-bearing precast concrete wall panels. It had 2,800 square feet of 15-inch load-bearing insulated panels for the exterior elevator shaft walls. And that's actually gives you the feeling of how diverse these products can be. Now, of course, it had 6,400 square feet of 10-inch precast hollow core floors and 1,000 square feet of precast concrete landings. So all these parts fit together with the 25 flights of precast concrete stairs and 115 linear feet of structural precast concrete columns. See, basically it's a large Lego project. And you've got all these decorative cornices that are cast in place and designed to lock together. So it's important to remember that all these exposed precast concrete elements and insulated walls, landing stairs, everything are designed to be pre-finished, and of course all that quality control and fit is done in the factory. So then when it gets to the site, it's literally just an installation process. It's very straightforward, a very, very tidy project, and of course the longevity and serviceability of that project during the entire life cycle of the project is enhanced. And you see some work as it was going in. So we're going to now listen to what a contractor thinks about how it is, and this is a contractor that hadn't worked with precast before, of what they thought of what the precast system was like.
Hi, I'm Kevin Juby from Manshield Construction. We built this. The way this project was designed allowed us to construct faster than conventional methods. Our mechanical and electrical trades, which are key to the process, were on the first floor snapping lines and starting rough-ins while the precast on the 3rd floor was being built. This system provided us an enclosed structure and a controlled environment which afforded our teams maximum productivity through the winter months. I believe we have helped Covenant Health set a new standard for care facilities moving forward.
Now, I played the role as construction manager on that Fort McMurray project. And honestly, once we showed everybody how things were supposed to fit and how things were supposed to go, I spent most of my time sitting in the truck. I didn't have to do a whole lot. It's pretty intuitive. It's much easier to get a quality project and people understand what they're doing. And you're not dealing with as many people. You're dealing with high quality people that know what they're doing. So from a contractor's point of view, it's actually a lot easier to build with this system. Now, you don't always get the chance to build boxes. You have to build something a little bit more interesting. And this project in Calgary really represents what can be done. And it's just one small example of what can be done. So this fully precast project was very cost effective. It was on a brownfield suburban site, which had basically a real challenge being right near the river. And of course, they wanted a French provincial design for that area because it held a prominent position in the city skyline. So this project here had 4 and 5 stories tall, so it's not always big, tall buildings, with unique upper levels that had a distinct appearance for public green space. Special attention was paid to the building envelope in this case, leading to 86,000 square feet of R20 insulated exterior walls and the appropriate windows already installed in the manufacturing plant. And that basically eliminated any need for winter hoarding. If you are in Alberta right now, winter hoarding is probably important to you. Actually, most places in Canada, even BC right now, suffering from some of that. They had large windows and balconies incorporated wherever they were possible, so you're not restricted to any of that with the precast systems or any other modular system. They're often coordinated, and it had 2 levels of interconnected underground parking for the building. Precast concrete was chosen for its inherent resilience and fire resistance, and that was vital for a project like this. Here's some photos of the project under construction. And you'll see in this next photo, someone was asking about it, yeah, that's a panel flying in. You notice the windows and everything are already installed. So fit and finish, quality's already been proven at the factory. All you have to do is assemble the panel. Now, here's another project where quality was really important. And it looks very similar to the one in Fort McMurray, but it's not. It's not the same one. But you'll notice that affordability was a big issue with this one. So back in Ontario, this is in Cambridge, they decided to go with this fully precast ABC solution for this one project here for the Saginaw Gardens apartment. So highlights of these apartments include, they were 7 stories tall with 122 exceptionally appointed inside suites. So again, the structure had to be affordable. They were going to put the money into the interior finishes, and the building had to show quality throughout. They chose precast modular in this case to deliver all of that cost effectively and still drive a very high premium out of the market for these types of projects. One of the things that's interesting here is the soundproofing and fit and finish, but the soundproofing is vital. For the project in Fort McMurray, one of the buildings literally is up against a 4-lane highway and next door to a fire engine, or a fire station with fire engines and everything. And we could watch the traffic going by at peak rush hour and watch the fire engines leave with the lights flashing, and the only way you could actually hear them is if you opened the windows. You couldn't hear the sound through the walls. So the quality is there. This total precast solution was selected because above and beyond everything else, its ability to deliver the speed of construction, its efficiency, its improved safety, but really the big thing for them was quality and aesthetics and unparalleled ease of maintenance. This is going to be a big feature they were going to sell to their people who were, the clients who were going to buy their units. This multi-unit apartment included over 1,200 advanced precast elements. And some real thought was put into this, and it had 10-inch hollow core floors. It gave them 154,000 square feet. The project also included 1 level of underground parking, which is pretty standard. So basically, that's what those panels look like. Again, nowadays, of course, they're usually flown in with the windows already in, doors already in, but this is how this project was going together, and it did produce a superior project in Ontario. So you can see how the superior fit finish, you can literally count on one hand the number of people on site, and yet the efficiency of building is superior. So we're going to look at a little bit more here. This is a video from the manufacturer of that project that we've been seeing videos on before, and this kind of really gives you a graphic feel of how this project could move so quickly.
Armtec Precast found a need in the continuing care market for a fast and sustainable construction method. Our solution begins with an insulated sandwich wall panel, which includes an exterior concrete skin with variable finishes, a continuous layer of insulation, and the load-bearing structure. Having the structural mass of concrete inside the insulation enhances the thermal storage properties of the wall. The pieces are built off-site in a controlled environment with tight quality control. The beauty of the design is the repetitiveness of the construction. After it's coordinated through a BIM model, it's like putting together a Lego set. We were able to build the shell of the building in no time at all, allowing the contractors to do their work inside. And while one wing was being built, another crane was already starting on the second wing. The precast construction continued from the main floor to the roof and included all pre-stressed hollow core slabs, columns, delta beams, stairs, elevator shafts, and the wall panels. We were able to construct the building in 4 months, compared to conventional construction time of 16 months.
Now, I wonder if any of you are listening to the term delta beam and wondering what's the delta beam? Well, we've seen a lot of these systems move along to incorporate hybrid systems. An example of this is these Luxembourg condos in Quebec City. They basically, you want to go to an ultra-modern, very clean, very slim line. And these designs, again, high-end product. So they wanted a really slim floor structure with long spans. They wanted to be able to, have all the benefits of the modular construction. They wanted this really clean, high-level fit and finish. This is where you go into these hybrid systems where we're starting to use precast with other material methods, and they can be very, very advantageous. So this building here was 6 stories tall at 90,000 square feet with ultra-modern floor space, lots of open area. We're going to show you photos of that. It uses Delta Beam system, which is a Finnish-based company from the Peko group. They basically come in with this pre-engineered steel beam system that's designed to carry precast and bring precast to another level as far as the kind of look and fit and finish you can do. So it's a really great hybrid system. It increased the clear bay size to 26 feet by 36 feet, which gives you a lot of room for just open floor plans and putting walls where you'd like. These larger bays also allowed for more parking stalls in the underground parking. That's a big advantage. Now it's, you're working with something that maybe is a slight premium, but the benefits of that are just huge. And of course, they used an advanced slender wall precast wall system, which really improved the building envelope. And I take my hats off to the industry here, the precast industry. They really do a great job in meeting or exceeding the requirements for building envelope and energy efficiency. This hybrid ABC system basically was able to do 12,000 square feet in every 3 to 4 days, produced a fire rating system, was up to 4 hours and 2 hours for the columns. What was the cost? Well, only $22.37 per square foot for all the Delta Beam components, the precast concrete elements, and the concrete topping and erection. That's a pretty good price if you think about it for a really superior floor system. It's really a great price, and I was quite impressed with this. An example of how a typical floor progressed for this project, well, it looked like this. You got day one, you're installing all the composite columns, Delta Beam, and precast concrete shafts to the entire floor. So all your vertical elements for that floor go in. Day 2, installation of 6,000 square feet of 10-inch precast. And that just literally goes in, locks together, and gets grouted. Day 3, another 6,000 square feet. Day 4, you do your topping and any miscellaneous works. This could move that project along at very high speed. You've got your insulated exterior walls as well, so you close in very quickly. What you end up with is a really clean, really wonderful looking project, very modern, very open. You notice the spans between the columns, the vertical elements on that one picture. And you can see how light everything looks. That's the delta beam you see there running across the picture. And of course, this is how much space you get inside. Now, of course, we've been doing this for a little while. A good example of this approach, ABC approach, goes way back into the 60s for the, in San Antonio. It was I believe it's a Hilton. And this has a great deal of history. It's actually part of the historical tour you take of San Antonio. In 1968, right down on the waterfront, right, only one block away from the convention center, they did a 21-story high-end hotel, fully modular. This is all a precast, actually. You can see pictures of the modular units going in there. And it's still there. It's one of the things that everybody goes and sees. While it was being constructed, they were putting 17 units in a day. Now, basically, everything was put up and installed in 46 days, and most of the workforce was a relatively small workforce, operated a safely and clean climate-controlled manufacturing plant. The installation force was very small as well. And one of the things that's interesting here is as these systems get developed, they actually create industries within communities to service areas that really are looking for this more modern, more sustainable way to build. And that is really a bit of a spin-off for these sorts of things. So Texas has really benefited from the foresight that this project brought to it. Another project that I like to talk about is a Moshe Safdie project you might have heard of in Montreal called Habitat. Back in 1966 for Canada's Expo. They built all these units. Now it's part of a World Heritage Site, but that's a fully modular project. And you can't tell me that that looks like it looks like a bunch of boxes, to be fair, but it doesn't look like a standard box. And it's considered a premium project to move into in the area. It is, and it stood up very, very well. Today's technology is even better. But you can see how really wonderful that looks. And that's an example of what we've been able to do. So the ABC process relies heavily on incorporating modular and prefabricated elements, and that's what it means. And this is why precast seems to work very, very well, because it's a modular prefabricated element. This approach can be used for the design and construction of basically anything. And the pre-planning is really key to its success on that project. The ABC process embraces modular and prefabricated elements, as I mentioned before, and it really changes the way we think. To really get the full effect of how ABC works, we want to look at a number of factors that make that work. So is it time for a shift? Absolutely. We've got to make this work. So you have to start with a project charter. Everybody has to be on board with the process from the beginning. It is rare that you can start a project with a different system and switch midstream. It does work, but it's rare. It takes somebody who's really got courage to switch midstream. If you start this way, your success rate goes way up. It includes getting everybody in the project team on board, developing a specific business case that really supports ABC. There's a process of sub-tendering, and of course you do something called job order contracting with regards to moving a project forward. And I'll explain what those items are. Why we do this? Well, you can see all your planning happens up front. This is where all the benefits come from. So you do this integrated design process we've been talking about so much. I've been in many integrated design process projects. The most successful ones are highly modular. Both sub-tendering and job order contracting incorporate the ABC processes, and it reduces unnecessary levels of engineering and design, because you basically put the engineering and design fundamentally with the subject matter experts, and then your engineering team are there to make sure that everything meshes with the intent of the project. So basically the quality of engineering really improves. The opportunity for not having any gaps or unnecessary overlaps have been also reduced. So here's a project that really champions the just-in-time approach for using the ABC approach. This is a project in Fort McMurray that I was on, and you notice there's nothing in the way of a laydown. Those trucks just arrived. You can see panels being lifted off and moved on. You notice in some situations we still have plywood on the windows. We stopped doing it. The windows weren't getting broken on the highway. There was no reason to do anything like that. This was the first project, so we didn't have the panels pre-finished in the factory. All the subsequent projects that we did on that site did have pre-finished panels, but the embossed finish was already in there. So here's some advancements in construction. Basically, they had everything pre-fitted, pre-finished for all the appliances or piece of equipment that needed to go in there. You'll notice that if you can look at the number of people working there, you just see 3, and that was your standard crew for something like that. So you can actually set these up to do all sorts of technologies that are now being put in. There are technologies that are coming out there that can even harvest waste energy from things like appliances or mechanical equipment that can be installed, pre-installed in the factory and put into these modular pieces rather than actually trying to do something after the fact on the project. So there's some real benefits, both structure, fit and finish. They can certainly meet all the seismic requirements. And of course, they're fireproof. So here's an example of some of the inspection work that goes on. So inspection and payment for ABC processes basically happen up front. You actually have to have a lot of this process developed early on. You're basically, there is a process that the funding institutions are comfortable with regards to securing the rights to the product before it goes on site, so you don't have to worry about paying for something that's not on site. It actually is considered on site. There are unique product codes that go against this, so it can be something that you have to deal with your financing institution with regards to how things are paid for. But the monies that are put in for payment and deposits are secured, and the owner still gets their product at the end of the day. So taking possession of an ABC modular project is not any different in the long-term thinking than doing a standard in situ project, but you don't have the problems with fit, finish, delay, all sorts of things. You get a better product for less money. ABC project before it's delivered to site. So you end up with a deficiency list that's extraordinarily short on an ABC project, rather than some that I've recently dealt with 400 deficiencies on, and it took 6 months to get all cleared up on it. And it was a nice project, but it still had lots of deficiencies. So that was built on site. If we would have been able to do an ABC process, I don't think I would have had as much work in dealing with that. Of course, commissioning is easier, and turnover to the building is faster and easier. Remember, most of your systems are pre-tested and pre-fixed. Even the mechanical electrical systems that are put into the modular units that are brought out to the site can be pre-tested before they get on site, so it's just a matter of a final test. Your operational readiness for the project, especially if you're a building operator and you want to, you're doing an office building, and you want to make sure that day one you open the doors, everything works, and you can just operate like you've been there for 20 years. This is very possible with an accelerated building construction project. It's fully modularized or highly modularized, so you get a lot of stuff pre-commissioned and it's ready to work day one. That saves you a lot of time, a lot of money, a lot of headaches, makes everybody happier with it. Of course, CPCI have a life cycle assessment of precast concrete buildings. It really shows clearly that these buildings last longer. They have a better, they have a better kind of a value later on in life, and actually we'll show you a little bit later on, many of these pieces can be repurposed for other projects in the future, taking away the concern or the thought that this is not a sustainable way to build. As soon as we modularize anything, and if it's durable enough, you have something that's extraordinarily sustainable. And that is really the secret of being sustainable. Let me speak to that a bit more. Here's a project where the building panels actually came from a previous precast project. They were modified and reinstalled and used for this community center in Quebec, but it originally came from a Canadian Tire store. So, it obviously was good enough for Canadian Tire that it was good enough for this community center. The project ended up saving a lot of money, excuse me, and a lot of time, because the materials that were originally used were so robust. Today's modular units, precast modular units, are even more sustainable in that regard. So you end up with something that is reusable, repurposable, something that does last for a long time. There's no sense in throwing it away. So in conclusion, a precast ABC modularized project has very little downside, a lot more opportunities. In fact, you have to really go out of your way to find a downside to any modular project if it's properly set up. Precast concrete is an exceptional product in this system, and therefore, when properly engaged, you get allow great artistic expressions, a very economic way of doing something, very sustainable. We look at the economics of this all the time. Certainly time saving, and you end up with a better building for a shorter, better building, better quality, shorter period of time, something that withstands all the forces you're having to deal with, better in the climate that we're dealing with today. All sorts of reasons we should be going this route. So that's all I have for today. Certainly open to questions and any comments you might have. You've got my contact information there, and I'm looking at our little question board. So I'm just going to look at the question board here a little bit more. The reduction in labor is magnificent, I'm reading, but decreasing the number of manpower to 6 instead of 50 or 80. Will it affect the community stability, sustainability? Actually, it actually improves it in some respects, because you're turning over poor jobs for good jobs. Quite often you're expanding the manufacturing base, and many of the trades that would work on site actually show up at the factory and do the work there. What's the highest energy performance completed to date? Any passive house projects? I don't know about passive house. Certainly that's on the horizon. I can get information on that. I know that modular projects, I'm working on a project right now in Fort St. John, which is passive house. It's using highly modularized products, not the precast realm, but it doesn't limit, going ABC does not stop you from being, from having these high performance projects. I know that the precast industry has product that will meet that. Are HVAC and electrical systems installed separately? They can be, or they can be part of it. The one thing I didn't show you on the Fort McMurray job was there was a modular penthouse that was lifted up on the roof, and the mechanical electrical systems were already in it. It wasn't part of the precast package, but it was something we did as part of the modular format for those projects. So that could easily be done. Did I mention that this is being used on the Burrard, down by the Burrard Street? Yeah, it's called Vancouver House, and I did mention it. It's called Vancouver House. Much of the exterior balcony systems are all a modular system that were put on the outside. It's an iconic building. It's one of the most attractive buildings we have in Vancouver. If you get a chance, look up Vancouver House, and you will see some very cool modular building units on that project. Do I have information on the air tightness? I don't have it in this showing. I'm sure I can get that, or we can get that through to you through CPCI. The R values can meet or exceed anything that's out there on the market today using this. And again, the energy performance right now is something that we can, any ABC product can meet any energy performance thing. Certainly precast can as well. Have there been any projects where interior of habitable spaces were included? Well, the example was the hotel. That was all habitable. They just shipped them up. We were putting 17 units a day in when those were going in, so that was pretty fast. Our foundations buildings, precast too, they can be, and I've seen systems where they have been done where they interlock. Typically, they're cast in place right now in Canada, but there are methods and means of doing that. Without getting into detail, how do you accomplish a building envelope barriers, continuity? I'd have to get into detail, but these panels are all designed to overlap, and therefore they bridge over any thermal bridging, or they kind of layer over any thermal bridging. The systems are designed to make any of these modular buildings totally compliant with the highest energy standards that you'd have for building envelope. You don't need any protections for transportation, as I found out, and that's practical experience. It's amazing how resilient precast concrete is to take down the road. How do you achieve the traditional brick and exterior wall look? Well, it was embossed, and then in the factory they did a great job of doing a stain and finish that literally matched almost perfectly what they had in the neighborhood. So it really comes down to how well you can perform that. You can do that in a factory setting where you can't do that on site. So you can match exterior existing looks very, very well. What do you think the primary constraint is using ABC? The biggest issue using ABC in downtown Toronto, I think, is really the mindset of the developer and the people who finance it. Everything can be done. Traffic is, you're going to obviously have larger pieces coming downtown, and you're going to have to lift those larger pieces, but timing that with traffic is actually pretty easy. You're not screwing up traffic over longer periods of time. So really it comes down to, in high urban settings, comes down to getting people to think differently. And I think that's where the opportunity is in high urban settings, to really rethink how we build, because that's where you can really do that. Depending upon the location of the factory, transportation costs can range greatly. It's not as high as you'd think, especially when you consider how much is included in the panel system or the modular system that's coming to you. If you actually added up all your transportation costs for all the shipping of standard in situ projects, it's actually quite a bit more than if you were to modularize everything and put it in. Even though you pay more per trip, you pay less overall. So I find this transportation cost issue one of those things that is truly a bit of a misleading thought. It actually is less if you think about the cost of transporting materials to a building if you modularize. And yes, you do get better quality concrete when you go to precast. Someone mentioned that. It doesn't require more quantity of concrete, actually. Someone mentioned it takes more concrete going precast. If you're, instead of doing a cast-in-place concrete building, actually it takes less concrete. And the concrete that we're using is of higher quality, and it lasts longer. So the environmental impacts, I mean, if you have an existing building that's cast in place, if you need to change the building, you're tearing the building apart, and you really can't take chunks of concrete and glue them back together and make another building out of it. With the precast modular approach, you can repurpose them. So I think that it really is more sustainable in many ways if you look at it in the full sense of the word. No, we've not had any issues with regards to smoke migration measures. Again, the buildings are all designed to meet all the requirements with regards to air seals and smoke situations. Again, this isn't your old precast. This is all modern stuff. Again, we're talking about accelerated building construction. We're not talking building a parking garage. When you're doing ABC from a project schedule management standpoint, how much of the entire project as a ballpark percentage are you seeing as construction execution versus initiation and planning? The whole schedule moves to initiation and planning, where the amount of effort at the very beginning, we had a graph of that. The initiation and planning stage starts very early, and it takes in some cases we can add about 20 or 30% to the time of design just by going through the initiation and planning. But you end up saving 50% of the construction time. So in effect, you about 2/3 the time to build a project, whereas typically, you know, half to 2/3 the time to build a project by using this system. Yeah, the CPCI does have that life cycle cost analysis. Just ask them if you want that. I'm just reading at questions as they come down here, happily to ask them. We're going to have opportunities in different locations to do this live, and of course I would be able to speak to you directly on that. The expansion of windows in the panel, basically the windows are designed to, and the panels are designed to move basically in a complementary way with the windows. And here's something I didn't mention. All the windows that came to the site for the Fort McMurray project were smoke tested before they came, because they were installed in the panels. They were smoke tested before they ended up on site. So we ended up with a superior installation of windows, which we couldn't have done on site because nobody smoke tests windows on site. Having that test done in the factory assured everybody that we ended up with a superior product for soundproofing, insulation quality, just better product altogether. We can't do that with an in situ project where we're building on site. So somebody asked about windows. So again, authorities are on board with it. You get them on board early, just so you know. Once they know it's happening this way, they actually prefer it. It's easier for them to be assured that what's going in is a superior product, and codes can easily be met or exceeded for all sorts of things. It makes it easier on the engineers. It makes there's a whole process that's set up for ABC that's much better than the standard process. A little bit more intuitive, and then quite a bit more checking on how things are supposed to go. I am just seeing if there's anything else I could. Oh, for LEED certification, our precast construction, precast can certainly do anything ABC can do LEED. They will provide the documentation with the proper amount of preparation, absolutely. That's the other question. Can this be applied to mass timber project? We're currently working on a project right now. It's a mass timber project in Ontario. Potentially, yes. Again, certain industries are further along with this than others. Certainly, precast is ahead of a lot of industries in this, and I will give you that. I don't know how the mass timber industry is coming along with that, but I know that they're working towards it. But it can be done for mass timber, and we've analyzed that approach a couple of ways, and we've done a number of mass timber projects as well as a cost consultant. All right. Well, I appreciate everything from everybody. The questions are fabulous. Be happy to, you got my contact information. If you need to reach out to me, please feel free to do so. I know Chris was sending me something. So Chris, if you wanted to send me a quick email, I'll pick up from that. But again, CPCI have lots of information on this. A lot of times I'll just send you to them. But if there's something specific you want to talk about, I'm happy to address it. Thanks all.